Dear students, I welcome you all for the online learning platform for the course Warehousing Automation. This video lecture will take us to the fourth chapter of Unit 4 Decision Making Processes in Warehousing Automation. Okay, so let us have a very small recap in a fast case. What are the things we discussed in the earlier presentation? See, as of now in Unit 4, we discussed about the need and necessity of decision making. So why decision making is essential in the context of warehousing automation? What is decision making? Why rational decision making is essential rather emotional decision making? Then how to go ahead with the design and implementation and types of DSS, that is decision support system. So how it has to be done, whether it has to be an individual's opinion or it has to be a consensus of a team. So likewise we discussed in the earlier chapters. Then chapter 3 took us to a very important thing of business goals and objectives, how the business goals are to be developed and how the objectives should be there. So in the sense, goals should be generic, perhaps the objectives should be very specific with several examples we just discussed. Then the next 3.1, chapter 3.1 took us to technology selection and investment decisions. What all are the various factors are there based on which we are just selecting the technology, right from vendor selection to vendor evaluation. So all the relevant details in and around technology selection and investment based decisions, that is involving risk assessment and ROI, were discussed in the previous 4 chapters. Okay, that is chapter 3 was divided into 2, 3 and 3.1. So now the fourth chapter is going to be cost, scalability and compatibility, and the second of a fourth will be optimal deployment strategy. So this is what we are going to learn in this particular presentation. Okay, so with this recap, we'll just dwell into the topic. So before we get into the optimal deployment strategy, let us discuss about the first point, that is cost, scalability and compatibility in technology. See, now we are living in a very sophisticated age where it is called as age of information. Okay, so everything is digital, where we have got technology almost for all walks of life, right from the start of the day, right from dawn to the dusk. We have got technology being governing our life at all walks of that day. Okay, so in a common man's life itself, when you have got technology, the role of technology in such a crucial case means, think of the role of technology in an industrial environment where the technology gets outdated with respect to time, it becomes obsolete with respect to time. Okay, so we should have a very good thought process in this regard, so that the technology what we adopt today should not get volatile maybe over a period of time, say within a month or two. Definitely it should not be of such. So how the platform should be developed is, we should have a technology in such a way that it should help us in attaining the strategic goals of the organization, that is business of the organization. As well, it is supposed to have a platform for development in the near future. Okay, today you are having, say for example, USB, regular USB version. Okay, maybe tomorrow USB-C might be coming into picture, like the way how we have got charging pins have got changed. Then tomorrow some other technology will be coming. So we should have at least a provision being made available into our controllers or control system in such a way that it is going to have a facility for upgradation. So that has to be thought of. So in short, we should forecast what will be the near future, and based on that the technology has to be selected. Okay, so for such developing an optimal deployment strategy, we are going to use 3 platforms. Okay, platform number 1 is going to be cost, second scalability, and the third is optimal, that is compatibility. So this is what the core agenda of this particular chapter. Okay, so with this understanding, first we'll understand why cost, scalability and compatibility are the core of decision making. Okay, see, first foremost thing is, we do business function, right? Engineering activity, when it is going to be added with respect to the performance from the market perspective, it is called as business, not with respect to profit and loss. I want you to get clarified in this regard. We are not going to deal with profit or loss. Our focus will be, engineers focus will be whether the customer's requirement has been fulfilled or not. If it is fulfilled, obviously our performance will be good. So that is where our focus is going to be all upon. We are going to converge with respect to it. Now, one of the performance is going to be the cost. So, obviously, the technology what we adopt, we are going to put a part of the investment over the rate of the product. So, that is where cost comes into picture. Then the second thing, scalability. So, the moment when we consider scalability, it is where a concept of considering the exponential growth of the organization in the near future, and compatibility is the term for adopting technologies in the near future. So that's where these three elements forms the core of decision making. First, cost consideration. So let us put a term called as CapEx, that is initial capital expenditure, that is nothing but initial investment. So how an organization is going to bring up or attract initial investment? So maybe by means of the company's own expenses, or maybe from share market, likewise they would have got somewhere. But how this capex is going to be dealt? So usually from a warehousing context, the first foremost costliest equipment will be robotics and associated equipments, say namely AMRs, autonomous mobile robots, conveyor systems, ASRS, automatic storage and retrieval systems, RFID scanners, radio frequency identity scanners and associated elements and sensors. So when you start with the deployment strategy, the first foremost thing will be we will be spending a lot on robotics and equipment. Then second thing, if the organization is not in a position to 100% deploy such high level technologies, then they can think of retrofitting with the available things. Okay, it may not be the same, but even that can be thought of. Why? Because we are thinking about optimality. Optimality means we should have some cluster of options. So one of the options, some group of options will be there, bunch of options will be there. So from this bunch, maybe one we might be in a position to select based on the constraints and conditions. Okay, so that's where even infrastructure has to be thought of. Some cases, as we discussed in the layout configuration, the aisle configuration has to be redesigned, it has to be reconfigured. And the third will be software. Obviously we should get into a WMS software. So for that integration with respect to ERP, if a dedicated WMS is not possible, then obviously we go for ERP, and we should have some sort of modern implementation of modern algorithms for the effective operation of the warehouse. Okay, so these all are the main things what we focus on the cost consideration. The second thing will be OPEX. So first was CAPEX, capital expenditure, and the second element is OPEX, operational expenditure. So under cost, we are learning different aspects. First aspect was CAPEX, second X is nothing but OPEX, that is operational expenditure. So the first foremost activity in an operational thing will be definitely energy. So energy is going to be the main thing. I'm coming in the reverse as far as the presentation is concerned. So energy, because all of a sudden you bring all sorts of robotic or conveyor systems or ASRS systems or carousel based systems. So obviously power consumption will be on the higher end. Okay, it will not be like regular case, it will be in the upper hand. So energy consideration will be the main thing. Then second, we should go ahead with reskilling of labor. See, today we have got a traditional machine, lathe machine. Tomorrow we wanted to come out or implement or install a modern CNC lathe. Okay, now operator, though he knows working of a lathe, but he never knows the programming part of a CNC lathe. So they are supposed to be trained, they are supposed to be upskilled, nurturing has to be done. So for that we need to spend a lot. Okay, so labor cost comes into the second aspect, and the third will be maintenance. Okay, so no equipment is going to be of zero maintenance. Maybe on the book we can call the equipments are zero maintenance, but theoretically no. So maintenance activity has to be carried out. So that will be a good percentage of OPEX. Okay, so cost, I want you guys to recall, the first was CAPEX, capital expenditure, then the second was OPEX, that is operational expenditure. Now, what is the strategy pertaining to cost? Now, it is not within our reach, it is not within our limit how to go ahead with. The first case is, think like this. Strategy number one is go for phased rollout. Okay, reduce the capex, shock and help fine tuning ROI estimation. See, today you have got a very big plant. You need to have some 10 conveyor elements, some 10 sophisticated conveyors. So the cost might be in a very huge way. It might be Herculean in nature. So therefore, what we can think of is right now buy some one or two for this particular financial year. For the next year, think of two. So likewise, you can think in terms of phased way. With a brief interval, you can think of. Then the second thing is start with high impact areas. So we have got several warehousing processes, the processes which is going to have high impact as far as technology is concerned. Without this technology, manually it is going to be a high risk, or it is going to be so crucial, means think doing in that particular area rather than doing all the other things. Okay, identify the vital few and try to do as compared to trivial many. Then consider robotics as a service. Models fit to shift capex to opex. Now this is a new term, RAAS. So I want students to be recollected. There is one concept called as IaaS, that is Internet as a Service. Okay. So today we are working, our country is working in this particular rate. There are operators are there where we just go ahead with their extension of their services for the case of internet. So IaaS, Internet as a Service. And today I'll tell you, today companies are working in a very interesting way. I'll tell Morris Garage, MG, they have developed a concept called as BaaS, Battery as a Service. So what is the biggest aversion with consumers as far as electric vehicle is concerned is the life of battery, how the battery will function with respect to time. So if the vehicle is going to have its own fixed battery, obviously we'll have that own fear. So in order to get rid of the fear as well, to induce the confidence among the consumers, what MG company they did is they came out with the concept of battery as a service, something like a rental system. So as a service means rental mechanism, okay, but not exactly, but it is in the lines of the same, something like a rental. Say for example, we just wanted to do some sort of cooking for our family members for some family occasion. We need to buy utensils. Is it advisable to buy utensils of large volume, or is it advisable to go ahead with rental? So rental will be the best. Why? Because we are going to use it only for a while. So for that, rental is going to be the best opportunity. So likewise, there are some cases where robots are offered as a services. Okay. So if possible, that can be thought of, so that what happens is the first element capex can be minimized and opex, operational expenditure, can be thought of. So this is how with respect to cost, the optimal strategy thinking should be. Second, scalability. So how we are discussing is first cost element, then how the optimal deployment strategy. First element is over. Now second element, scalability, and further deployment strategy we'll think of. So scalability, modular system design. So today modularity is the need of the hour. Okay, modularity. Why? Because days are gone where custom built-in development was done. You go to a particular member, for example, you wanted to have a shirt. So days are gone where you go to a textile shop, purchase material, then come to a tailor, then ask him you to go ahead with. If it is a standard readily consumed item, directly go to a ready-made showroom, buy whatever the material you wanted to have, whatever the design you wanted to have, because sizes have been standardized. Okay, unless and otherwise, if it is not a standard element, then we need to think of other cases. So that is what is modularity. Okay, so modularity is going to be very interesting. Why? Because AMR systems have been developed which can be scalable. That is, the body will be, now as of now you will be using for say for 500 kgs. The same equipment, once you just retrofit with the new motor, the exact AMR can be used for some 1 ton. From 500 kgs, the same system, same accommodative element will be taking care of 1 ton. So just retrofitting of one element. So that is what is modular system design or modularity. Okay, so think with respect to such things. Then coming for WMS, warehousing management software. Now try to go ahead with cloud based activity. Why? Because you need not to confine yourself within one particular geography. You can go across the world. Why? Because you don't have a platform on the any geometry. You have just got only in the cloud. So anywhere it can be accessed, provided you have got an internet. So likewise, scalability can be thought of. The next is adaptability. See, adaptability is a very crucial element. Why? Because today multitasking is another need of the hour. So now to go ahead with this adaptability, please understand one thing. Are we using mobile phones only to talk? but the basic function of mobile phones was only to talk. That's how the mobile phones came into existence. But today they are mini computers. You can do almost all sorts of tasks what you are doing on a computer up to a major extent. Maybe certain things may not be possible, but almost all the things are possible in today's reality, because the system is highly adaptable to the situation. Even you can give printouts. Wireless printers can be connected and you can give by means of wireless applications. Yes, so that is the strategy. So adaptability, once there is a demand, the system should be adaptable. Once there is an expansion, the system should have a provision for adaptability. So that's how scalability has to be thought of. Then the next point is integration with future technologies. See, today we are having some cap with respect to technologies. Tomorrow definitely it is going to change. It is going to get revised. So we should think at least with respect to our forecasting knowledge, what are the technologies are available. We should have a provision in our existing setup. The one simple thing is IoT based mechanism. So today IoT is going to be the limelight, and tomorrow definitely it is the one which is going to we empower all the existing technologies. So we should think in such lines and develop the scalable concepts. Distributed operation. See, another alternative for scalability is, rather than going for multiple warehouses at various locations, think of distributed centers. I want you students to recall the concepts what we learned in Unit 1, distribution centers. So a warehouse is going to be on a larger volume, okay, but a distribution center is going to be only for the vital few element on a smaller scale, okay, frequently used item, and that too will be in the heart of the basic consumption area. So where your consumption is high, there we'll have a small distribution center. It is a miniaturized version of warehouse, so that we can reduce the cost. Consider a centralized versus decentralized control strategy. Okay, so this is another very interesting concepts. Today companies are moving in this particular perception. Excuse me. So the term centralized is having a hub. From the hub you transport everything is going to be centralized. Decentralized is for each and every term have a decentralized mechanism. Split them into various applications or geographical locations. Likewise it can be thought of, and that is what is decentralized control strategy. So that can be thought of. See, you are just going ahead with, or you are postulating certain things. If it is practical feasible, we'll adopt. If not, we'll think of some other strategies. So this is going to be the another important aspect. Now, what are the strategies here is, so don't ever start with application of technologies for the entire warehouse. Start on a pilot site, or only for one small department. If that department is doing well, think of horizontal deployment. If A department is able to do in a very successful case, think of implementing the same technology to the B department. So gradually you expand. Don't all of a sudden don't implement for all the departments, so that operation becomes a stance. It is going to become standstill. Don't do so. Do for one department, then from there you can slowly you can expand. Data driven scaling. So this is another important activity. See, data, we have been discussing a lot about data in this regard. Why? Because data is the one which is going to give us the direction. Which direction suits the best, we can understand only when you have a proper data. And the third element, compatibility. See, the term compatibility means accommodating the technology. That is what exactly it means. Okay. Now, today, I hope you generation students, we have not even seen an element, a memory storage device by the name floppy disk. There was one a memory storage device by name floppy disk. It used to be, say, somewhere in the size of the palm. Okay. It was a small thin wafer of a film was there. So it was something like the miniaturized concept of the present day hard drives what we have. Okay, not the solid state drives, HDD, hard disk drives. It was a miniaturized version. So all of a sudden it will stop work. So there was a floppy disks were there. Of course, like micro SD memory cards, even there were micro floppies were there. Then macro floppy drives were there. Even today, any software you see, the save button is nothing but the logo of the same floppy disk. Then the technology came CD drive. Then CD drive came into DVD drive. Then DVD drive became today the thing what we are using is USB. Okay, and HDD became SDD, solid state drive, SSD. HDD came into SSD. So likewise, in future, technologies are definitely they are going to get changed. So we should have a system which is compatible to go ahead with all sorts of things. I'll tell you one example of compatibility. When you see old CPUs, say the CPUs which were manufactured some 2 decades back, for mouse they will not be having USB button, they will have another peculiar type of button. For keyboard there will be a separate pin will be there. Why? Because it was considered to be fail-safe mechanism. But today everything has become compatible. Everything has been made with USB. Standardization came into existence. So thanks to the modular design, modularity was the one which paved foundation for all such compatible based activities. So that is what system integration is all about. Then the second, APIs and middlewares are essential for data flow between automation and legacy systems. So obviously we are going to have an hardware and we are going to have software. So there is going to be a controller between both these things, API, application program interface. So middleware we should use so that we can think of compatibility. Only middleware will be changed based on the technology. So physical compatibility. So physical compatibility means retrofitting. So existing thing has to get changed. So I'll give you one example, one simple example in this regard. See, today we are having two-wheelers. Now you are having an old two-wheeler which is of BS4 standards. And today you wanted to retrofit that vehicle to BS6 standards. Is it possible? Yes, the same frame, the vehicle frame, everything structure will be used. Only engine alone will be replaced. And today that is what Maruti Suzuki is doing. They are working R&D in this regard. Why to buy a new electric vehicle? You have got a petrol or a diesel engine, remove that engine and put in a retrofit in a battery setup, motor setup to it. Then try to use the same thing as an EV. So they are working in this regard. So that is what is physical compatibility. Then compatibility is various SKUs, stock keeping units, maybe with respect to size, shape or weight. Okay, another thing, what example I wanted to give is when demonetization was implemented in our nation. See, the size of the currency notes were different. Okay, earlier you might be knowing the 500 rupees and 1000 rupees were there. Then 1000 rupees was completely abandoned, and of course apart from demonetization it was abandoned. Even now we don't have any 1000 rupees. Then came new 100, new 200, new 500, new 2000 rupees notes. Think of whether ATM machines were changed. No, the same machines, but they were recalibrated. That is what is compatibility is various SKUs. Sizes will change. Still, the same machine has to be used. So some recalibration or some retrofitting, some minimalistic work we do in order to accommodate such changes. That is what the beauty of compatibility is all about. Workforce compatibility. So this is another crucial task. Why? Because you can't send all of the workforce out and you can't recruit a new workforce. So existing workforce should be given with the training mechanism, training module. So reskilling is essential in this regard. So importance of intuitive interfaces, training programs and change management. So motivate them to the changes. Now, what is the strategy here? Choose vendor agnostic platforms or open standards to avoid vendor lock-in. Don't confine yourself to only one particular vendor. Always have an option. If A is unable to perform this task, think of B. If B can't, have it C. Likewise, have multiple options. Prioritize interoperable automation systems. Okay, robots that can work with existing conveyor or racking systems. So reconfigurable setups should be available or it should be made available. So interoperability is one of the pillar for CPS, cyber physical system. Of course, we'll be discussing all these things in the next unit 5, the latest advanced technologies and its implications in warehouse, modern warehouses. Okay, so interoperability, please understand this term. Interoperability, reconfigurable systems should be thought of. Now, what are the phases and strategies we will see? So assessment and planning, think of cost benefit analysis, compatibility audit and KPIs. Likewise, go for pilot implementation. Do not implement all of a sudden for the entire plant. Only on a small pilot basis think of evaluation and iteration. So this is going to be a continuous process. So we need to audit, we need to review the process, then gradually scale up. Why? Because we just implemented only for a pilot and gradually we can think of scaling it up. And finally, integrate the entire system and fine tune the system so that we can get optimal results. So now total 5 activities we'll consider. The first is going to be capex, then it gets into opex, scalability, compatibility, and ROI timeline. So for all these elements, we'll be going ahead with ROI. So to start up with, think of a very basic system pilot category, then migrate to semi-automated, then finally make it fully automated. So all of a sudden, don't automate it right from day one. So what is the final recommendation here is based on the understanding, start with a pilot basis. So what is the optimal strategy? Start with the pilot basis on a very small scale. Focus on modular and interoperable designs so that you can reconfigure and use. Don't buy any sort of servers, everything right from beginning. Think of rental as a service, okay? Internet as a service based in such rental mechanism can be thought of so that capex can be reduced. Then operational ROI should be increased to the maximum so that we can minimize the capex. Then training the workforce is essential, so plan everything well in advance, not after the implementation of the technology you send them for training. No, when you're thought of to buy one particular technology, start the training program right from that particular day so that the system is optimal for complete implementation. So continuously monitor the metrics for all the KPIs and fine tune the system to reach the optimal functionality to increase the efficiency of the functions. Okay. So with this we come to the end of this presentation. So before I wind, let us summarize what we learned. So how, on what basis should we develop an optimal deployment strategies on the 3 platforms. Platform number 1 was cost, platform number 2 was with respect to scalability, and 3 was with respect to compatibility. So the final takeaway was like this. So think of doing everything in the pilot basis, reconfigurable or interoperable category should be thought of, and finally ensure maximum ROI we are getting so that the capital expenditure, also known as capex, can be minimized. So, and try to increase the operational expenditure OPEX as compared to CAPEX. So these all are the conclusions what we drew out of our discussions. So with this we finish the presentation. So I thank you one and all. So any doubts, please note it down. We can discuss the same during our offline or online classes. Okay. Thank you once again.